Hi and hello everyone. So today, me and my friends, we are going to talk about a heat radiation wave. So, what if I told you that a single scientific phenomenon is responsible for the colors of a sunset, the microwave that heats your food, the X-ray that checked a broken bone, and the text message you sent 5 minutes ago? Well, they seem like a totally different things, but they are actually identical siblings. So today we are pulling back the curtain on the hidden powerhouse of modern technology, which is a radio wave heating. While most of us associate radio wave with music in a car, they are actually used to weld heavy industry plastic, treat deeper tissue injuries in medicines, and yes, heat up your dinner. Over the next few minutes, we are going to explore how these invisible waves are shaping the industry and the medical world.
Electromagnetic waves are fundamentally transverse waves. This means they are characterized by oscillating electric and magnetic field. These two fields are entirely perpendicular to each other and the direction of propagation. These waves also travel at a speed of 3.0 times 10 to the power of 8 meter per second and do not require any material medium to travel through. The diagram below also shows exactly how these waves travel in three-dimensional space. Next, electromagnetic spectrum isn't just one type of wave. It can actually be divided into 7 groups based on their frequencies and wavelengths. These 7 groups are radio wave, microwave, infrared light, visible light, ultraviolet light, X-ray. Moving forward, the relationship between energy and frequency. This relationship is simplified by the fundamental equation E equal to hf, where E represents energy of a single photon, h represents Planck constant, and f represents the frequency of wave. This equation describes the quantities of energy in electromagnetic wave, where energy of a single photon is directly proportional to the frequency and Planck constant. This shows that when energy increases, frequency also increases. And this is why microwaves are effective for heating because it has high frequency producing.
Hello, my name is Afi and I will be explaining about how microwave actually heat up your food. Now, we all use microwave daily, but have you guys ever wondered about how they actually heat up your food? It's not just magic, it's physics. Microwaves generate specific electromagnetic waves that target the water molecules locked inside your meals. So essentially, the entire cooking process kicks off right at the molecular level. So, why water? It all comes down to chemistry. Water is a polar molecule, meaning it has an unevenly distributed electric charge. As you can see from the H2O diagram here, the oxygen atom is partially negative, while the hydrogens are partially positive. This creates a dipole, which basically makes water highly sensitive to electric forces. When you hit start on the microwave blasts these polar molecules with a rapidly electric field. Because that field is constantly flipping direction, the water molecules are forced to try and keep up. They end up rotating back and forth at an insanely fast pace, just like in this simulation right here. When all these frantic rotations spikes the kinetic energy of the molecules, they start moving faster and crashing into each other. Those constant microscopic collisions are what convert pure kinetic energy into thermal energy, creating heat. Now, I will pass it over to the next person.
Hi everyone, my name is Wanas Rasha. So today I will be explaining the application of radio wave fittings in our daily lives. So, as we know, in our daily life we use a lot of microwave ovens. But why? It's because it is so much faster, 4 to 10 times faster, and it can reheat your foods in a very low frequency. Therefore, it is safe to use for those people who want to reheat their foods for their kids. Next, we move on to the diatomy, which is widely used in the medical industry. But why? It's widely used in medical industry because when it use ultrasound to penetrate to the patient's body tissue, it will create heat inside the tissue. Therefore, it will improve the blood circulations, it will treating the patient's muscles, body, and also it will not surface burn, which means this patient will not feel any burns on their skin. So again, it is safe to use.
Thank you, Juan, and welcome everyone. Today we are looking at the advantages and limitation of radio wave heating and how the microwave in our kitchen actually work. The biggest benefit are speed, efficiency, and the convenience. Unlike normal oven that heat the air around it, Microwave launch energy directly into the food. The polar molecule like water that inside our food absorb this wave and vibrate rapidly, creating instant heat without needing a preheating. However, there are limitations. Microwave can cause uneven heating, leaving food hot on the outside but frozen inside. Material compatibility is also key. Glass and plastic don't absorb microwave well, while metal reflects them entirely, creating dangerous spark. From cooking and medical therapy, this technology is incredibly useful when handled safely. Thank you for your time. Now I will pass it over to my friend.
So, in summary, radio wave heating is a really important application that is widely used in many aspects in our daily life. For example, in healthcare, industries, the electronics, and communication technologies. Its ability to provide fast, efficient, and uniform heating in many our daily life applications. However, it still has some limitations, such as high equipment costs and the need for careful control during the operation. Despite these challenges, radio wave heating still play a significant role in improving modern technologies, increasing industrial efficiency, and enhancing the quality of life.